I see the interest, the potential application that you're mentioning, like being able to do in vivo diagnostic, see the margins, things like that, being able to reach organs or location of the organs that are hard to reach because of the size today of the endoscope,
Yeah.
right? Okay.
Yeah. That is true.
Question for you. So, still on fiber optics, you mentioned the fiber optics being used to actually bring the light and do the illumination of the scene. What about the fiber optics to actually see? Meaning that, use the fiber optic to visualize instead of sending the light, but more like as a receiving element.
Right. So, good question. Many, many years ago, when the first endoscopes were around, when I started in the business, the method, there was no video, there was no chip that was small enough to go into the end of the scope. So fiber was what they used. So you had a lens at the end of the endoscope. It focused onto the end of a coherent fiber optic bundle. That fiber optic bundle, which was thousands of strands, would carry through the endoscope coherently so that it would maintain the image, maintain an image. It was coherent fiber. And the doctor would look through an eyepiece and he would see the image. And that's how he was able to see through a colonoscope for many, many years. The downside to that was, at the time, how thin can you draw fiber? So obviously the thinner the fiber, the more resolution you had through the bundle. And, at times the fibers would break. So you would have a bundle that you would be looking through and you'd see these little black dots that look like essentially burned out pixels on a television or on something else in today's standards. And that was the way everybody looked through things. Video took all that away because once you mounted the chip at the very end of the endoscope, you no longer had to worry about having any type of coherent bundle which could or could possibly break or be damaged. And with video quality as high as it is nowadays and the miniaturization of video chips, you've got, at this point, a megapixel chip, which will give you better than 1080i or 1080p. Won't give you 4K, but it'll give you, a high definition image of the inside of a colon. So I can't imagine that they would move back to that delivery system for an image in a colonoscope or a gastroscope. Now, as we mentioned, we were talking about before, if you can get into the lungs further and further, or if you can traverse the common bile duct, there's a company that has a product called Spyglass, and it was based on an optical system, as we just mentioned, of a fiber optic bundle, and it was very thin, and it was inserted into the common bile duct so you could look for stones. The latest iterations of that product are now using a video chip because there's a chip that's small enough that they can fit in there and have decent enough quality. So I see the advantage as you get smaller and smaller still to using fiber optics. It's just, how good is the quality going to be? Now, I'm not going to lie. Traditional fiber optic quality won't be that good, but what you've described about with multiplexing, that's a different story. And not familiar enough with that. I haven't seen any of that in real world applications to be able to offer an opinion that says, oh, that'll look just as good or be just as, it's fine. Unfortunately, I haven't seen it.
Is there a way for us to quantify what's good enough? So, assuming we're interested in bringing the fiber optic imaging to bear in this domain, I wouldn't even know where to start saying, well,
sure,
what's good enough? What's the measurements of the video that you get? Can you give me some numbers or metrics?
Yeah. Okay. So let's talk about what's used in the U.S. and in developed nations versus what's used in emerging nations.